Good morning, dear student. In today's lecture, we will discuss the next important topic of our chapter lipids is that the saponification value or saponification number. So let us discuss what is this saponification and how one can find out the saponification value or saponification number. So these slides indicate the chapter lipids and the important point, that is determination of saponification value. So we already discussed the definition of saponification value. Again, we discuss it. We will discuss the next slide, that is the definition. What is saponification? The saponification value is the number of milligrams of potassium hydroxide required to saponify 1 gram of oil or fat. It is called saponification value. So the definition we already discussed, and we already discussed the difference between acid value and saponification value. So the saponification value is the number of milligram of potassium hydroxide is required to saponify 1 gram of oil or fat. It is called saponification. Let us discuss the next one, that is the principle for determination to determine the saponification value or saponification number. That is, the first point in principle is that whatever the sample, that is oils or fats, is saponified by refluxing with known excess of alcoholic potassium hydroxide solution. So you have to weight the oil or fat sample, and you have to take the round bottle flask, that is RB, and reflux the sample with known excess alcoholic potassium hydroxide solution. And the second point is that the alkali required for saponification is determined by titration of the excess potassium hydroxide, that is KOH, with standard hydrochloric acid, that is HCl. So in this titration, so you have to take excess alcoholic potassium hydroxide solution, KOH solution. This KOH solution, it is used for saponification of these oils or fats, and whatever the excess potassium hydroxide which is remain, then it is back titrated with hydrochloric acid solution. Let us discuss the next slides, that is the analytical importance. So what is the importance of this saponification value? The saponification value is an index of mean molecular weight of the fatty acids of glycerides comprising a fat. Means lower the saponification value, larger the molecular weight of fatty acids in the glyceride, and vice versa. So lower the saponification value, larger the molecular weight. Means it is inversely proportional, we can say that. So the value is decreases, molecular weight is increases. The value is increases, molecular weight is decreases. That is the analytical importance regarding to this saponification value. Let us discuss the next slide, that is the apparatus which is required for this determination. So we require 250 ml capacity conical flask with ground glass joints. Again, 1 meter long air condenser or reflux condenser to feed the flask. Then we require hot water bath or electric hot plate fitted with thermostats. So these are the apparatus which is required for determining the saponification value of fats or oils. Let us discuss the next one, that is the reagents. So which reagent is required to find out the saponification value? So we require first the alcoholic potassium hydroxide solution. So how this alcoholic potassium hydroxide solution is prepared? So you have to first reflux up to 1.2 liter alcohol 30 minutes with 10 gram KOH and 6 gram granulated aluminum or aluminum foil. So the alcoholic potassium hydroxide solution is prepared by refluxing 1.2 liter of alcohol 30 minutes with 10 grams of KOH and 6 gram of granulated aluminum or aluminum foil. and then you have to distill and collect 1 liter after discarding a few first ml 50, after discarding first 50 ml aliquot. So you have to discard the first 50 ml aliquot and then collect 1 liter of solution, and that is nothing but your alcoholic potassium hydroxide solution. The second reagent is we required the potassium hydroxide. So dissolve 40 gram of potassium hydroxide in this 1 liter of alcohol, keeping temperature below 50 degrees Celsius while dissolving the alkali. So alcoholic potassium hydroxide solution. So you have to reflux 1.2 liter alcohol 30 minutes with 10 grams of KOH and 6 gram granulated aluminum or aluminum foil. And the second important reagent is that dissolve 40 grams of potassium hydroxide in this 1 liter of alcohol. So whatever the alcohol which is we prepare first, alcoholic potassium hydroxide solution which is prepared first, in that you have to dissolve 40 grams of potassium hydroxide in this 1 liter of alcohol, keeping temperature below 50 degrees Celsius while dissolving the alkali. Then we required a phenolphthalein indicator solution because it is just acid based titration. So you have to dissolve 1 gram of phenolphthalein in 100 ml rectified spirit. And again we required a standard hydrochloric acid solution approximately 0.5 normal. So these are the reagents which is required, that is alcoholic potassium hydroxide solution, then we required phenolphthalein as the indicator, and then standard hydrochloric acid approximately 0.5 normal. So let us discuss the procedure for this determination. So the first point is that melt the sample if it is not already liquid. So whatever the sample which is required, it should be a liquid. Melt the sample if it is not already liquid and filter through a filter paper to remove any impurities and the last traces of moisture. Make sure that the sample is completely dry. Mix the sample thoroughly and weight about 1.5 to 2 gram dry sample into 250 ml Erlenmeyer flask. So this Erlenmeyer flask is nothing but your conical flask. So you should remember this Erlenmeyer flask is nothing but your conical flask. So you have to take 1.5 to 2 gram your sample into 250 ml conical flask. Then you have to pipette out 25 ml alcoholic potassium hydroxide solution into this flask. So you have to take excess, that is known excess volume of alcoholic potassium hydroxide solution. So in this case they have taken 25 ml alcoholic potassium hydroxide solution to this flask. Conduct the blank determination along with the sample. So parallelly you should take the another conical flask and the another conical flask which does not contain any sample. So simultaneously you have to take the sample along with the blank. So in one conical flask there is a sample, and in the second conical flask there is no sample, but you have to add all these reagents except the sample in blank. So you have to perform blank also as well as the sample. So conduct blank determination along with sample. So you have to take the sample, you have to add alcoholic potassium hydroxide solution, reflux it, then cool it, add phenolphthalein indicator and titrate the excess KOH with your standard hydrochloric acid solution. So same procedure is performed for blank. So blank means without samples. You have to add only alcoholic potassium hydroxide solution, then reflux it, and then you have to add phenolphthalein indicator and titrate with hydrochloric acid solution. Okay. So this is the procedure. So you have to perform both back as well as blank. So back. So let us consider back for the sample and blank for without sample. So conduct blank determination along with the sample. Connect the sample flask and the blank flask with air condenser. Keep on the water bath. Boil gently but steadily until the saponification is complete. The saponification is indicated by the absence of any oily matter and the appearance of clear solution. Clarity may be achieved within 1 hour of the boiling. So after the flask and condenser have cooled somewhat, wash down the inside of the condenser. So after the flask and condenser have cooled, so you have to wash down the inside of the condenser with about 10 ml hot ethyl alcohol hot ethyl alcohol neutral to phenolphthalein. Okay, so then, so to give the washing, or in many procedure, the step is not performed. So you have to cool the solution, then you have to add phenolphthalein indicator and titrate the excess potassium hydroxide solution with zero point 0.5 normal hydrochloric acid. So let us discuss the next slide, that is the calculation. So the saponification value, it is given by the formula, that is the 15.61 56.1 into B minus S into N divided by W, where B is the volume in ml of standard hydrochloric acid required for the blank. So you should remember what is B. It is the volume of standard hydrochloric acid required for blank titration, means without sample, without fats or oil. So whatever the alcoholic solution you have to taken, which is reflux, and then you have to titrate with hydrochloric acid solution, whatever the volume of hydrochloric acid is required, or whatever the burette reading is considered, it is as capital B, that is the volume in ml of standard hydrochloric acid required for the blank. Second, S means the volume in ml of standard hydrochloric acid required for the sample. So whatever the sample we reflux with alcoholic potassium hydroxide solution, and we know that, so some of the potassium hydroxide, it is used for saponification process, and whatever the remaining KOH which is present in the flask, then you have to titrate this excess potassium hydroxide solution with hydrochloric acid solution, and whatever the burette reading is nothing but your S, that is the volume in ml of standard hydrochloric acid required for the sample. Again, the capital N is the normality of standard hydrochloric acid, and W is the weight in gram of the oil or fat taken for the test. The factor 56.1, it is nothing but the molecular weight of your potassium hydroxide. So you should remember this formula. Saponification value, that is 56.1 B minus S N, B minus S into N divided by W. Okay, so you should remember this formula and the terms, that is what is B, what is S, what is N, and what is W. So this is regarding to the saponification value, determination of saponification value by volumetric method. So at least you should know the basic principle, then the apparatus, the procedures, and the formula for calculation of saponification value and its analytical importance. So this is all about the saponification value. In next lecture, we discuss the next important point of this chapter, that is the iodine value or iodine number. Thank you.